So in order to solve this one, we have to find the lowest common denominator. Now this one right here can actually factor. And that's the first thing you want to do, is you want to factor that. And so I'm going to pull out a GCF and call that 2k minus 3. And I'm going to cross that out, just to remind myself that's the new denominator. Now, with that, if you look at these two denominators, usually what you do is you take the biggest one, and then you start looking for what do I need from the other one. So if I take this, doesn't it have the most stuff? Okay, then if I call that my LCD, say my LCD is 2 times k minus 3. Let's say that's my LCD. Now, okay, go over here. Do I already have k minus 3 in that?
Yeah.
Do I need more than just that one? No, it has it all in it. So I don't need to bring more into the LCD. We're good. We just can use that bigger one. So the key is sometimes you have to factor your denominator to get a little bit cleaner. So now I'm going to multiply everything by the LCD, which is 2k minus 3. This one's by 2k minus 3, and this one's by 2k minus 3. So I multiply all tops by that, which is basically saying multiply both sides by it. And what you'll notice here, the k minus 3's disappear over here. In the 1, it doesn't disappear, but on this one, the whole thing disappears. And it gets kind of messy, if you can see. There's a lot of baggage and stuff sitting around. But for this first piece over here, do you notice there's a 2 times a 2 left?
Yeah. Mm-hmm.
So we start over here with a 2 times 2 equals. Okay. Over here we have a 1 times all this. So is 1 times anything, just leave it?
Yeah.
So we'll just take for that, let's just ignore the 1. And could I distribute the 2?
Yeah.
So can I call that 2k minus 6?
Yeah.
And right here, what's left? Is this a negative 3?
Yeah.
Which we could just say minus 3. So we got 2 times 2. We got that is 2k minus 6, and right here is a negative 3. So now the denominators are all gone. It becomes an easy solve. But you have to do some cleanup first. So hopefully you notice, let's clean this up. So we got 4 on the left side. 2k, and negative 6 minus 3 is negative 9. Now to solve this, don't we move the 9 over, the negative 9 over?
Yeah.
So I'm going to add the 9 off. 2k equals, what is that, 13? And then which way, do we divide off the 2 or the 13? Divide the 2 off. So k equals 13 over 2. Now, will 13 over 2 create a denominator of 0? No, because my restriction here is 3, which here it's also 3. That's not 3, we're good. 3 would cause an error that doesn't. So we have solved it nicely. For this problem right here, if I want to solve it, I need to get rid of these h's. So my LCD, can you basically tell your LCD is going to be h? So h, because they're both all h's. So what I'm going to do here, I'm going to multiply everything times h. And watch what happens when I multiply everything by h. Those cancel, and I'm left with h squared, oh, not equals, that's minus 5 equals negative 6. So I'm left with h squared minus 5 equals negative 6. And now I got to solve this. In order to solve this, what I do is I add the 5 over, and I get h squared equals negative 1. And now I have to solve this. And there's a way to solve it. What you have to do here is you have to square root both sides. We did this last semester. When you square root both sides, you get rid of a squared, you get h equals plus or minus the square root of negative 1. The square root of negative 1 is imaginary. You can't get it. It's impossible. So the answer here is no solution. Because my answers are imaginary. So I have no answers to this because the answer I get is imaginary, which doesn't work. So it malfunctions. If that was a positive one, my answer would be positive or negative 1. But it's not. So it doesn't work.